This is Dr. Holt. I'm going to go over several of the UT problems that you guys are struggling with. Number 8, vector A has a magnitude of 8 and points in the positive x direction. So I would recommend you just create yourself some type of axis system here. Oops, let me get that back to the pen. Our line here. Come on. There we go. Draw this down here. That'd be my x-axis, hopefully, if I can draw a line. X-axis, this is x and y right here. Okay. First one, 8 points in the x direction. So I'll show a vector here. It's going to go off this direction here. I'll color that. I'll make that red. It's going to go on the x-axis here. It has a value of 8. Vector B has a magnitude 20, makes an angle of 36 degrees, the positive x-axis. So again, we're going to show this vector up here. This 36 degrees. Again, okay, now you're doing A minus B. This vector has got to go back the other direction here. So I will just draw another vector. Going to go because you're subtracting. That's all you're doing here. At this point, identify your vertical angle. This angle is 36. This angle here has got to be 36. So this is your 36 degree, because again, those are vertical angles. Let me just erase this part right here. All right, just go ahead and label this with the magnitude. This will be 20. All right. Now we get rid of this because you've already negated it. You made it in minus b, so this is gone. So really, all you're doing is you're adding these two vectors together. Pictorially, what would be if I take these, I'll clone these, and if you're confused, just I would recommend you do this because this is really what you're doing. We're adding vectors. So 8 plus the 20. Again, when you add, you go head to tail. And this will give you a good idea if you've got your head in the right direction. So your resultant has to go like this if you're adding it graphically. But we're going to do this mathematically. So we start out with vector. We'll do the vector. We'll call this A. I'll call this vector A here. I guess that is A and B. And this is the B. Okay? Alright. So now, we'll make this B prime because we made it go the other way. So now we're going to do vector A. We're going to list the components, and the only components you're going to have is going to be 8. And what are we doing? Units? Did it give you units? No, it did not. So 8, comma 0. That is a component form. Now to do B, this is going in the negative x direction, so we're going to take 20 times the cosine of 36. 20 times cosine 36 gives me a value of negative 6.18, comma, and the y component of this is going to be going down, so that'd be 20 times sine 36. That gives me negative 11.756. Okay, those are component forms. Again, if you're confused about this vector, about what direction the components are going to go, just keep coming back to this. There's your magnitude. Your components have got to go this way and go back down this way. Again, tail, tail, head, tail, head, head. Alright, at this point, all you have to do is add these together. And you add the 8 and the negative 16. So negative 16.18 plus 8 gives me a magnitude of negative 8.18. Zero give me this, gives me negative 11.756. Okay, so those are the component forms of that vector, and we'll call that just vector C, or actually we'll call it R as the resulting vector. Now to get the magnitude of R, we just do Pythagorean theorem. We take this squared plus this squared and take the square root. Again, make sure when you square these that you put them in parentheses. and I take the square root of that number, and I get a value of approximately, probably my answer is going to be a little bit different, 0.3219. And the answer they got was 14.3218. So close enough. Alright, so that's how you do number 8. Number 9, vector A has x and y components of negative 20 and 20. Again, draw yourself a picture. X components, we're going to go negative 20 here. Let me get a vector. I go negative 20 here. Draw this. Again, I show it as 20. The arrow makes it negative. Let's say, and then 12. Make this 12. Again, this is vector A. This is vector A. And if you want, you can call this the AY component. And you can call this the AX component if you'd like. Alright. Let's see. And then you have B vector has X and Y components of 12 and 17. And again, make sure all the units are the same. In this case, they are. Like if you're in centimeters and meters, you have to be in the same unit. It doesn't matter which one you're in, but you have to be consistent. So I'll make this 12.7 and make this negative 20. And we'll put these centimeters on here just to keep it consistent. Alright, so those are going to be the BX. This would be the BY. Alright, and okay, it says they're equal to 0. So we're going to go ahead and find out what A minus B is first. So if I'm going to do A minus B, basically what I'm going to do is I'm going to add A and B together, the components, but I'm going to negate the B, make it negative, or change the sign of it. So we'll list the components. A 12, comma, oops, I got those backwards, sorry. Negative 20 centimeters, comma, 12 centimeters. Now B, again, we're going to negate B. We'll make it negative B. That's going to give me negative 12.7, comma, 20 centimeters. Okay, we're going to go ahead and add all those together. So negative 20, that gives me negative 32.7. And 32 centimeters. Okay, so that's all that is this A vector minus B vector, doing the component form. Alright, now it says that 3C is equal to A minus B. So we'll just come over here and we'll say 3C, it said 3C plus A minus B, okay. So 3C plus A minus B is equal to 0. So what happens, can we not say that 3C is equal to, move this to the other side of B vector minus A vector? Because really all I'm doing is moving everything to the other side. To do that, I'm subtracting A and subtracting B, so it changes the sign of those. So could we not go back now and say that B vector minus A vector is equal to, the component form would be positive 32.7, comma, make it centimeters, sorry, comma, negative 32 centimeters. Okay, now all you have to do is divide everything by 3, and let's see, are they looking for the magnitude? Probably are, okay. So we're going to divide each of those by 3, because we're just doing algebra. So if I take 32.7 and divide it by 3, we're slowly getting this. We can say C is going to equal to that value divided by 3, which will give me 10.9 centimeters. 32 divided by 3. 32 divided by 3 gives me 10.67. So there are the component forms. And the problem was asking you for your x component, so this is a value of 10.9, which is exactly what we had here, 10.9, and then ask you for the value of the y being negative 10.67 centimeters. Okay, again, not that difficult, just kind of work through it in a methodical sequence, and you should get this one, get these right. Let's look at this one. Find the magnitude direction of two vectors where r is equal to a plus b, the vector angle 180 degrees. Okay, now this one, you guys really shouldn't struggle with this one. Because look, all you have is, you have one vector 11.1 going this direction here. It says angle of 180. So you make that 11.1. You have another vector 16.9 angle 58. This is 16.9 meters. Okay, you know the angle here is 58.1. Okay, all you're doing is you find a plus b. So isn't a component just going to be negative 11.1? Again, any units? Yes, meters, comma, 0. What is the b component? B component, all you're going to do here is take 16.9 times the cosine of 58.1. 16.9 times cosine 58.1, that gives you a value of 8.93. $16.9 times the sine of 58.1. Gives you a value of 14.347. Okay, it says a plus b minus 11.1 plus 8.93 gives me a value of negative 2.8. Okay, we'll call this R1 vector, comma, 14.347. Okay, so looking for magnitude. So isn't magnitude just going to be this 2.8 squared plus 14.34 squared? So let's do that real quick. It gives you a value of 14.61. Let me see where I'm off a little bit. Because I can't read my writing, let's look at this real quick. 14.617. Let's see, I'm off just a little bit. 11.1. Yeah, okay, 16.9 angle from the positive horizontal. Okay, try it again. 16.9 times cosine of 58.1. Just check my math here. 8.93. Okay, looks good, but minus 11.1. 2. Oh, there's my problem right there. I can't add. That's not very good. Don't know where the 2.8 came from. .1693. Let's try that. Plus 14.347. Gives me 14.5108 roughly, or 07. So yeah, don't make the mistakes I make, but I do make mistakes. So that gives me a value of 14.51. Okay, what's the magnitude of the vector difference of A minus B? Well, okay, if you're going to do A minus B, the only difference you're going to be here is you negate. You make anything that's positive, make it negative. Anything that's negative, make it positive. So both of them here would be negative. So now you have 11.1 plus 8.93 gives you a value of 20, negative 20.03. This gives you a value of negative 14.347. Again, just go back to Pythagorean theorem. gives you a value of about 24.638. Alright, let's look at some more. Okay, on 15 we're going to do B minus A. So let's go back. Try to grab, okay, I got this grabbed. Let's say, edit copy. Come back over here, let's see if we can paste this in. Do it again. Edit, copy that. Come back over here. Let me get rid of this too. Edit, paste this down. Bring us down here. Alright, now we have to go back and change the signs of these what they were originally. Okay, A was negative, but if I remember right, B was all positive. So we'll get rid of this and this, and let's go back and make sure that's correct. Yes, B had positive values. Okay, now we're going to do B minus A. So if I'm going to do B minus A, all I'm going to do is negate A. Make everything as negative positive, anything as positive negative. So we're going to add these together, and I think we're going to get an answer. It was very similar to what we had before. 11.1 plus 8.93. Add those together here. That gives you the 20.03, comma 14.347. Again, you should put your units in here. That's what B minus A would look like. So again, go back to Pythagorean theorem. Take square root. I got 24.638. Yeah, it matches that exactly. Alright, now it says what is the angle between 180, the resulting vector that you have here. Okay, what you would do here would just draw your vectors. This would be 20.03 going this way, and then 14.347 going this way. This is your resulting vector. This is the angle you're going to look for. So all you have to do is take the inverse tangent of this side, which is the 14.347, divide it by this side, which is 20.03, take the inverse tan, that should give you the 35.6135. Alright, last problem. 4 vectors. What's the magnitude of the vectors? Okay. If you think about this, this problem's really not bad, because you're doing is adding 42, then another 42, then you come up here and doing 42 this way, and another 42. Again, you're just adding vectors. So you know right now that this sum of this would be 84. The sum of this would be 84. You know the angle is 55 degrees. So if I'm going to do the magnitude, again, write this in component form. This is B plus C. Isn't that just going to be 84 meters, comma 0 meters? Because this one has no y component. When I do A plus D, I'm going to take 84 times the cosine of 55. 84 times cosine 55. That gives me 48.18. (84) times the sine 55. 68.088 meters. Now add these together. So we'll go back to 48.18 plus 84. That gives me a value of 132.18 meters. This just comes down to 68.088 meters. Again, magnitude. Just go to Pythagorean theorem again. Take the square root of that. And your magnitude in this case would be 148.686 meters. So that's what A plus B plus C plus D magnitude would look like. And that's it. Alright, there's several problems I've gone over. I hope this helped you to finish the UT. All right, best of luck.